All right. Hello, my friends. It is May 11th. Yes, May 11th. We have one more week of live lessons. I hope that you guys are figuring out how to get to the different drop-in supports, finish up your DBAs, and do all the things you need to do so that this semester, as hard as it was, is not going to be in vain, right? Each teacher that I've sat in with so far all this week is having tons and tons of extra drop-in supports to help you guys get to the finish line. Of course, I'm available. I am allowed to do what I can do. I'm not the content teacher, but if you need help with anything else that you feel like I can help you with, I am more than happy to try and help you with that. Okay, I cannot do the DBAs, but if you want to practice with me, we can, depending on what the subject is, because all of these subjects are not my best, strongest skill, right? That's why we have the general ed teachers. So we're gonna focus a little bit on congruence and similarity today for math, just to touch up on one of the last couple of things that I've noticed we were doing with Miss Wright's class and Miss Quinn's class. This is under geometry, which is also part of algebra as well. So we're going to start off with this video, of course, and then we're going to do the vocabulary game, of course, and then we're going to practice some together, and then you guys are going to practice in quizzes, okay? All right, so hopefully I'm sharing my screen because I don't see the green.
Flocabulary in the building.
You know,
how is everybody feeling?
Yeah. Okay, thank you, Adolfo.
To know if two figures are similar, you have to analyze. They have to have the same shape, but not the same size. It could be a pair of squares or a pair of triangles, a pair of trapezoids or a pair of rectangles. The corresponding angle measurements are the same, but their sides are different lengths. Am I clear when I explain? You represent the similarity with a symbol called a tilde. Don't trip, I'll give you a visual now on the two figures that are congruent. They had the same shape and same size. Be a student of the game. The corresponding angles and sides are the same. Let's plot two on a coordinate plane. Take triangles, A, B, C, and D, F. Wanna see if they're congruent? Here's what you do next. Put one on top of the other, it's like it disappears. All of their points match up, is that vision clear? You represent congruence with an equal sign and a tilde over it. Store this in your mind. The process is called rigid transformation when we move the figure, but the size and shape are never changing. Congruent means the same shape, same size. You can see if two figures are congruent with your eyes. Use rigid transformation. Test, don't guess. If every side and angle match up, that means yes. Congruent means the same shape, same size. You can see if two figures are congruent with your eyes. Use rigid transformation. Test, don't guess. If every side and angle match up, that means yes. There are three types of rigid transformation. The first type is called translation, which is moving all the points in the figure in the same direction by the same amount, not bigger. Listen closely, I got a clue. The SL should remind you that slide is what you do. For example, take triangle DF, move it 2 units up and 2 to the left. The second type is rotation, that's a fact, kid. Like how the earth rotates around its axis. First step, find a point on the coordinate plane. For real, then spin the figure like a windmill. You describe a rotation by the point and angle. So let's look at a triangle and make the rotation point to origin. You see and rotate the triangle around at 90 degrees. The third type is reflection. Here's a tip. The FL should remind you we gotta flip over a line to create a mirror image. It's called the mirror line, not the line of scrimmage. Now check out this scenario. Reflect triangle DEF over the y-axis. There we go. It maps perfectly on the triangle ABC, so they are congruent. That's easy as 1, 2, 3. Congruent means the same shape, same size. You can see if two figures are congruent with your eyes. Use rigid transformation. Test, don't guess. If every side and angle match up, that means yes. Congruent means the same shape, same size. You can see if two figures are congruent with your eyes. Use rigid transformation. Test, don't guess. If every side and angle match up, that means yes, yes.
All right, my friends. So there's a lot of vocabulary words packed in this one little video. It's simple in logic if you think about it, but when you start having to plot it on coordinate planes, that's where it gets a little tricky. So if we narrow down and like really hone in on the vocabulary words, it'll help you when you start plotting it onto the coordinate plane grids.
Flocabulary in the building.
All right, so vocabulary words. And remember, all of these handouts are going to be part of your announcement when I drop the video from this class, so that you can download it to your computer and keep a copy for study guides or for notes, okay? Congruent. It means having the same shape and size. The circles are congruent. You could put one directly on top of the other because they're the same size and shape. A coordinate plane is a grid formed by two lines, the x-axis and the y-axis, that cross at a point called the origin, which is dead center in the middle and is usually the ordered pair 0, 0, okay? The ordered pair 3, 2 sits on the coordinate plane, which is made up of an x-axis and the y-axis. The 3 would be the x-axis because the first number is always the x, and the y is the axis, second number. And a tip that I always give my students is first a baby crawls before it can stand up and walk, okay? So first x-axis, then stand up and walk on the y-axis, okay? All right, corresponding is having the same relationship or function or matching. So triangles ABC and DEF have corresponding angles. A and D are the correspondings. They're both on the left. C and F are corresponding. They're both on the right. B and E are the same, are corresponding because they're both on the top. Okay. That doesn't have anything to do with the size. It has more to do with its location. Okay. Mirror, a mirror line. Think about when you look in the mirror, you see exactly what you're putting in front of the mirror. Okay. It's a reflected object. This is the line that the object is flipped over. So when you see a reflection in a mirror, it's, I don't want to say opposite, but it's flipped. I guess I can't think of a different word. So the left is on the right and the right is on the left in a mirror image, okay? The origin is the point 0, 0 on the coordinate plane, which is usually dead center of your coordinate grid, okay? That is where the X and the Y axes cross, okay? If an ordered pair is 0, 0, then it is located at the origin of the coordinate plane, which is represented by this red circle right here. That 0, 0, you're starting directly on the bullseye target. You're not moving to the left or the right, and you're not moving up or down. You're dead center. Okay, that's the place of origin. Reflection, when a point or shape is flipped across a line, it creates a mirror image, okay? A rigid transformation is a transformation that does not change shape or size. It can reflect, it can rotate, and it can translate, which means slide, the SL, slide, or move in position, okay? Those are the three transformations that we're working with mostly. I know there's one more, I can't think of the name right now, but we did not use that too much in the Alex lessons when I was in class with Miss Wright. So it's reflection, which is the mirror image, rotation, when you rotate it or turn it or spin it, and translation is just slide to the left, slide to the right, slide up or slide down, okay? Rotation, turning an object around a set point at a certain number of degrees without changing the size or the shape, okay? Similar, same. We talked about that a lot in ELA this week and last week because we were talking about synonyms. Synonyms are similar words. In math, similar also means the same. So they are similar shapes because they're both triangles, even though they are different sizes, okay? So similar shapes have the same shape. They not necessarily have to have the same size though. All right, a translation. Remember that SL in the middle of that word is slide. That's when you move or slide an object to the left, to the right, up or down. You're not flipping it though. You're not turning it. You're just sliding to the left, sliding to the right, sliding up or sliding down, okay? All right, let's give it a go. Let's see what beat we're gonna make today. Ooh, so 20 questions. Okay, let's get started. All of you help me out. Let's take turns. Throw it in the chat. Help me out. All right, the object was turned 45 degrees around a fixed point. That's called what? Is that rotation, translation, or reflection? Keyword turn, 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 turn. Yes, Adolfo, thank you. Okay, help him out, guys. To know if two figures are blank, you have to analyze. They have to have the same shape, but not the same size. Is that corresponding, congruent, or similar? Yeah. All right, Adolfo, 2 for 2. Where's Elric at? Where's Tyreek? Come on, let's go, let's go. When reflecting an object, this is the line the object is flipped over. Is it the congruent line, the mirror line, or the origin line? You're reflecting, you look into a piece of glass, it's called to see your reflection. Yeah, good job, Elric. Yes, Adolfo. Okay, okay. I see you, I see you. All right, we're about to add the hand claps. This process is called blank when we move the figure, but the size and shape are never changing. Is that a coordinate plane, a rigid transformation, or origin? Good try, Tyreek. A coordinate plane is the grid that we can move it on, but what are all three of those processes categorized under? Is translation, rotation, reflection are all examples of rigid transformation. Good job. I'm so proud of you guys. Good, good, good. Let's keep going. When a point or shape is flipped across a line, it creates a mirror image. Is that a reflection, a rotation, or a translation? Yeah, Elric, fast on that draw. I'm proud of you guys. All right, blank means the same shape, same size, similar, corresponding, or congruent. Same shape, same size. Same shape, same size. They are similar, but if they're both the same shape and the same size, what do we say? Math. Similar can mean they are the same shape, but not the same size. Corresponding means the location. So if a shape is the same size and the same shape, it is congruent. Congruent is the same shape and the same size. Reflect the rectangle across the blank dotted in red. Reflect the rectangle across the what? Rigid transformation, rotation, or mirror line. The key word is reflect. Yeah, to reflect in a mirror. Good job. All right, we're about to add the drums. A grid formed by two lines, the x-axis and the y-axis that cross at a point called the origin. Is that a rigid transformation, a translation, or a coordinate plane? Sometimes called a coordinate grid. Yes, the coordinate plane. Good job. All right, with that blank, the square wasn't flipped or turned. It was just moved 3 units to the right, slide to the right, slide to the left. What is that? A reflection, a mirror line, or a translation? When you slide. Yes, translation has the SL for slide. Good job. In math, having the same shape and not necessarily the same size, is that congruent, similar, or corresponding? Yes, now y'all got it. You're halfway through, good job. What is that red circle in the middle called on that coordinate grid? Is that a mirror line, a rotation, or origin? Yes, Tyreek! Didn't even let me finish. Yes, Adolfo. Good, good, good. All right. Moving or sliding the object a set distance without changing its shape or size. You're not flipping it, you're not turning it, you're just sliding it or moving it. Is that mirror line, a rotation, or translation? This is a good beat today. Last couple of ones have been kind of ugh. When you slide to the left or slide to the right, what is that called? Mirror line, rotation, or translation? Rotate is spin, like those chromey wheels on my car. Are we rotating if we're just sliding to the left or sliding to the right? Oh, a mirror is just reflecting what you see in the mirror. Slide to the left. Yes. So translation has a SL. Help that remind you of slide. Translation, slide. Oh boy, I think they're starting to mess up my beat here. All right, what is this a picture of? A reflection, a mirror line, or a coordinate plane? Yes, that is a coordinate plane. Yes, thank you guys. All right, if a point ordered pair is 0, 0, then it is located at the blank of the coordinate plane. Is that the rotation, the origin, or the mirror line? Zero, zero. Oh, oh, oh. Origin. Oh, oh, oh. Oh, oh, origin. Yes. Thank you, Tyree. Absolutely. All right. What is that picture showing us? A reflection, a rotation, or a translation? The shape changed in its position, location on the grid, but it's still the same size and it's still the same shape. As a matter of fact, it is exactly the same shape and size. Yes! Woohoo! Yes, yes, good job. You can change the position of an object without changing its size or shape using what? Mirror line, a coordinate plane, or a rigid transformation? Mirror line, yes, you're just reflecting what it is. You didn't change it. Oh, shucks. I'm so sorry. A rigid transformation. That's what you said. I'm sorry, Tyree. So you guys beat the teacher on that one. I thought it was mirror line because that's what they just showed us. Okay. I apologize. All right, drag the word that belongs to this picture. What's going on there? What did they show us with this? Was that an example of corresponding, congruent, or similar? You guys are smarter than me already. Doesn't take much. It is similar, but what's the like math term for when it's similar? When you analyze, put the shapes on top of each other to see if they are what? That fancy word. They are similar, but they're exactly the same size. They're exactly the same shape. But what do we call that? Corresponding is when you're talking about the angles of a triangle being in the same location. Congruent, yeah, same size, exact same shape is congruent. Oh, I don't know what that is they added. I don't know. They're messing up my beat. We will come back to that when we add the last instrument. Triangles A, B, C, and D, E, F have blank angles. The A and the D are in the same location. The B and the E are in the same location, and the C and the F are in the same location. Would that be congruent, corresponding, or similar? Yes, Adolfo, yes, that's where you plug that word in. Good, good, good. All right, turning, 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 turning an object around a certain point, a certain number of degrees without changing the size or the shape. Is that a rotation, a mirror line, or a coordinate plane? Turning. Turn, turn, spin, 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 turn, turn, turn. Yes, rotation. When you rotate, something is spinning or turning. A pair of trapezoids or a pair of rectangles. Their blank angle measurements are the same, but their sides are different lengths. Am I clear when I explain? So the A and the E are in the same spot. The D and the B are in the same spot. And the C and the F are in the same spot. That's locations, right? But they're different sizes. So would that be corresponding, reflected, or origin? Talking about the location. Yes, yes, that's the hard one without pictures. I wish they would give us more pictures for this one. Corresponding, good job. All right, no, 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 no. You guys got 20 out of 20. Ms. Garcia. I know that breathing thing, I'm not too fond of that. All right, remember that all of these handouts are gonna be uploaded so that you can download them onto your computer and use them as study guides when you're completing some of your assignments for this topic, okay? All right, so we have a few minutes. I wanted to practice a little bit with you. I'll type in the answers as I can. I hope I can. Using my, that's okay. I'll have to draw. I'm not that great at it, but I'll do my best. All right. All right. So translation, remember that the SL means slide. So all we're doing is moving it to the left or sliding it to the right in a translation, okay? Nothing is changing. You see the 3 dots on the top are the same. Squares, I'm sorry, with the dot in this box on the far left and 3 boxes going down. Nothing changed about that, okay? Reflection, you look at this letter T of boxes, now it looks like eyes are looking at each other because in a mirror, you're looking back at exactly what is being shown in the mirror. This is the mirror line right here. So this is a reflection, okay? The size and the shape didn't change, but it's reversed, okay? So now instead of the eye being on the right, the eye or the dot is on the left, okay? And then look at this T. Now he's kind of flipped on the side of his head, okay? And his eye or his nose is face down. So we rotated the shape, but it still has 3 blocks on the top and it still has 3 blocks going on the middle. So we did not change the shape. We did not change the size. We just changed the way it's standing. So it's not standing up like a T anymore. Now it's kind of on its head, okay? So let's see how many of these we could get done together. You're gonna tell me if the shape is a translation, a rotation, or a reflection. And this is the model that we're comparing the 3 to, okay? So look at this shape. It's kind of like a little bird maybe. 3 little boxes on the middle, 1 on the top for the head and 1 on the bottom for the foot in the middle, okay? So this is how the shape is in its original location. What's going on here? Did we translate it? Did we rotate it? Or are we reflecting it? It's hard on a 2D paper because you don't see it like moving as you would in a 3D video or a graphic. But look at the eye. Let's think of this as an eye, and this is like a little birdie. So look at the bird standing up in this picture. Right here, what is the little bird? Yes, he's rotating. Yes, because now his eye is facing down. Maybe he's trying to peck at the dirt to get a piece of worm out of the dirt, right? So he rotated. He spin his neck around. And I'm gonna try my best. I might just have to write R-O for rotate, okay? All right, look at him right here. His eye is standing back up. His head is back up. You can't tell, but would that be an example of him sliding to the left or the right if he's standing in the same exact position? And if he did slide, what would that be called when we slide to the left or slide to the right? It should have drew an arrow. So let me draw an arrow. So he moved over 3 spots. Well, what is that called? Yes, it's a, no. It's not a reflection. He changed his position by sliding to the left or sliding. Well, I put the arrow, so he's sliding to the left. I mean, to the right. Well, he's sliding to the left for me, to the right for you. He just moved over. His shape and his size stayed the same. Is that a translation, a rotation, or a reflection? Well, it's not a reflection. So he's here and he's scooched over and he's right here now. His head is still standing up straight. Is that a reflection, a rotation, or a translation? Started right here. He slid over here. Yes, it's a translation. Good job. It's gonna take practice. It's okay. It's hard. It's hard on a piece of paper to understand what they're asking you. It's easier when you see the video of the picture moving. All right, so TR for translation. Now look at this picture. His eye was facing to the right. Now his eye is turned and is facing to the left. What is that? His size didn't change. His shape did not change. He went from this way. Now it's this way. His image is flipped. So he didn't rotate. The image is flipped. When you have an image that's flipped, yes, it's a reflection. Good job. All right, let's try number 2. Adolfo, you answered all of these for number 1. Let me hear Elric or Tyreek help me for number 2. So look at this, kind of looks like a Pac-Man, okay? Let's think of him as the Pac-Man. His eye is facing to the right. Now on this picture, his eye is facing on the left. Is that a reflection, translation, or a rotation? He didn't turn, he flipped. It feels like a rotation because he would have to like spin to go like this, but he didn't spin. The image is just flipped. I used to have a mirror in here. I don't have a mirror. Yes, Elric, good job. When the image is flipped in a mirror, we call it a reflection. All right. Now look at the Pac-Man. He's facing this way. In this one, he's still facing this way. I'm going to give you another visual clue and say he slid to the left 5 degrees. He did not spin, he slid. What happens when you slide? If you're a shape, is that a reflection, a rotation, or a translation? He just slid over a little bit on that coordinate grid. He did not rotate. He's not looking in the mirror. He just slid to the side. Translation, rotation, or reflection? I'll help you out and see if I can move back up. Remember when you slide, SL helps us remember that keyword that just says that we moved over a little bit. So what term would that be? Did he reflect? Did he translate? Or did he rotate? It's hard to think about it. I know. But just let's see. My pencil is right here. And then I moved it right here. I didn't rotate it. I just slid it over. So it's here and I slid it over. Didn't change the shape. I didn't change the size. It's not looking in the mirror. I did not spin it. I just slid it over. So is that a translation, a reflection, or a rotation? Adolfo, can you help him out? It's hard on a worksheet. It's only going to come by practice. I just moved the pencil over to the left just by sliding it. I don't know if you can see my pencil because it's like weird on my camera, huh? It's not picking it up. Boop, boop, boop. Just slide to the left. Yes, Tyreek. Yes. Translation. Translation is when we just slide it over. All right, now look at my pencil. Whoop, fell on its side. Is that a reflection, a translation, or a rotation? Whoop. Look at my pencil. Yes, it's rotating. Good job. Awesome. All right. Well, we're at the quarter mark, and I want you to have time to practice on your own because the pictures will be more vivid for you to understand what the question is asking you than this 2-dimensional flat worksheet. But you guys did awesome. I'm really proud of you. So I'm gonna throw the link in the chat for you. It is, and if you need to do it, my quiz.com. Game code is 50609. Okay. Remember, it's 15 minutes per question, so take your time. Remember, you can take it multiple times if you want to, and you could practice with the flashcards before you take it again if you want to, okay? And it's not a graded assignment, it's just for me to know, okay, they got this, we can move on, or we are struggling a little bit in this area and I'll do it again next week, okay? All right, I'm gonna stop the recording. Thank you guys, you were so amazing today. Thank you for coming. I'm gonna put my mic on mute so you can focus and concentrate.